Danielle Peterson from CPD On Demand. Today we are talking to Henk Smit. He is the Managing Director of Vovani Water Products, and we will be discussing membrane technology as an option for water and wastewater treatment. Thank you so much for joining us today, Henk.
Thank you very much.
Now, membrane treatment technology has become one of the preferred methods for treatment in many countries. So can you tell us a bit about what the technologies are and what's available?
Yeah, well, on the membrane side, we have different technologies, and it goes through from microfiltration to reverse osmosis, depending on your application. And luckily, we are in a state now where worldwide these technologies are easy to get and implement. So many years we've got only the conventional treatment options, but now we've got the membrane technologies to treat various types of water, and especially now in Cape Town, desalination.
Okay, so can you tell us about some of the benefits of using membranes?
Well, the benefits most of the membranes is you've got a physical barrier. So whatever you're trying to remove, microorganisms or ions out of the water, when the feedable water comes in, you have a physical barrier, and after your membrane, you've got the quality that you require. For some of the conventional treatments, when you have different water coming in, and the water might be sometimes better, sometimes worse, your quality can differ afterwards. But with membrane technologies, it doesn't matter if the water incoming feed water quality goes up and down, your quality afterwards will always be the same.
Okay, so if you were to compare it to a conventional system, how do the two compare?
Well, for conventional treatment systems, your footprint is much bigger. So there's lots of civil works involved, there's lots of operator attention, lots of people required to work on these conventional systems, and they must be very skilled to do that, to do certain things correctly. Well, the membrane technologies, your footprint is much smaller, so you can build these systems into small buildings, and you don't have lots of operators required. You have a couple of operators, just looking after the system and more monitoring and making sure the chemicals are there, but most of these systems are totally or fully automated, and you can monitor these systems off-site at the offices where the company that's installed these systems can monitor it off-site, or even from a phone or a laptop or a tablet, and even run these systems from their offices. So your operator can just contact you and say there's a problem there, and you can start to stop a pump or start up the whole plant without even anyone touching anything at the plant itself.
Okay. And you've mentioned things like ultrafiltration, you've got reverse osmosis. Can you please run us through all of the options that are available and maybe some of the characteristics of each?
Yeah, for sure. There's four main membrane technologies, which is microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. So where microfiltration is more on the removal of microorganisms, and it's lots of used, especially in the food and beverage industry, for wine farms and water treatment. And then you go into ultrafiltration, where you get the removal of the suspended solids of microorganisms, but as well certain viruses as well. So it's a much higher removal rate, down to 0.01 micron. Okay. And after that, you'll go into nanofiltration, where you get the removal of monovalent ions from about 50 to 90%, which is a looser membrane, which we call the softening membrane, which is also good for process technologies, especially in the dairy market, where they make fetas, where you have to have separation of water and the whey, for example, the feta, to make the feta cheese. And then you get reverse osmosis, which is a more 90, 80, 99% removal of monovalent ions, which you'll use in brackish water applications and seawater applications.
Okay, so how do you go about determining the right membrane for the right application?
So when working with the end customers or OEMs, we always look at getting a first water feed analysis to see what's going on in the water and what's the application. Either it's a wastewater application or a drinking water application or seawater application, and what's the reuse of the filtration going to be, what the end user is going to use it for. And after you have all the information and know what the volume of water is going to be treated and the feed analysis, you can determine what the right technology will be. Because some feed waters, like or source water, so you talk about it's open source, or surface water would be rivers, dams, bores. You only need a certain step of filtration to get the quality for drinking water. But for example, now if you want to go for desalination for drinking water, then you have more steps, which would include reverse osmosis. So you have to look at the application and exactly what the customer's requirements is for his end use.
Okay, and obviously membranes work to remove the things that you don't want from the water. So can you tell us just in a bit more detail exactly how the membranes work to provide the quality that you want?
Okay, so most membranes are made of certain polymers or thin film composites. So it's a manufacturing process where they use these polymers to either extrude in hollow fibers or in flat sheets. And then they manufacture the membranes, which you'll see is a potted material, or either we call it a spiral wound membranes, where they take the sheets and round them up like for reverse osmosis and nanofiltration. So these are all physical barriers. So the water that goes in, especially on microfiltration, ultrafiltration, will go in. You have the incoming feed, and you'll immediately have your outgoing feed where your particles are retained. With nanofiltration, reverse osmosis, you do have two streams, which is your permeate and your concentrate. So depending on how you design your plant, the percentages of how much permeate you'll get and how much concentrate you get, you can determine. And there will always be a feed stream that you have to, with concentrate, you have to throw away, but the permeate will have the removed minerals. So these different membranes are manufactured for the different work that they should do. And it's from different companies and suppliers around the world. They use different materials, but at the end of the day, they all go to the same type of filtration to the end user.
Okay. And now, obviously, these membranes would have a lifespan, I would assume.
Yes. So if you look at microfiltration, ultrafiltration, we usually conservatively look at the lifespan for 4 to 5 years. And on nano and reverse osmosis, depending on the application, 3 to 5 years. Sometimes in combination with both of the filtration using pre-filtration, ultrafiltration, and then reverse osmosis, your reverse osmosis membranes can last longer because you have very good pre-filtration. We have had applications where your ultrafiltration membranes have last you 7, 8 years instead of 4 to 5 because the plant has been operated well and the membranes have been looked after. But the same with reverse osmosis membranes. If the plant is designed well, operated well, the membranes can last you longer.
Okay, so there are ways to improve your lifespan.
Yes.
Yeah. So in terms of looking at the lifespan and the replacement costs, how would you compare that to a traditional kind of treatment plant?
Yeah. In the past it was more expensive, but now with membrane technologies being so widely available and accepted, the price has come down a lot. Building right next to each other, you might still have a little bit more cost on a membrane plant because you do a fully automated system because your PLCs and SCADA systems are all expensive. But there's only a small capital difference, and if you look at operational costs over the long term, you always win with the membrane plant. There's lots of more operational costs on the conventional plant, and the quality can't compare. The quality you get out of a membrane plant immediately is a much higher level from a conventional plant. So with a conventional plant as well, where our in, like in South Africa, our in disinfection is dosing a lot of chlorine. With the membrane plant, you just have to dose a little bit of chlorine for a distribution network, and that's as much as with the conventional plants. There's a chemical saving there as well.
Okay. And then obviously they've got a smaller footprint.
Much smaller footprint. Lots of times you have only a certain space available to put in a membrane plant or the building or the civil works, to save costs. So conventional plants have much larger, but lots of more civil works to be done. And the membrane plants can be built off-site, come delivered, put on site, and quickly installed at a much quicker rate as well.
Okay, so the fact that they're more movable, how does that play into decentralized treatment solutions? I mean, if you're trying to do something off the grid or in a rural community where there's no formal infrastructure?
Yeah, it's with the membranes, it's easy to install it into containers or movable. So lots of people we deal with do that. So they install reverse osmosis and ultrafiltration, microfiltration, and different types of membrane technologies into containers because obviously they can build it on site in the facilities, move it to site, drop it, and disconnect. And it makes it easier because it's basically your building. It's protected inside. You don't have to put up a building or a massive amount of civil works. You drop it, plug and play, and you give clean drinking water to a community. So it helps a lot with conventional treatment. On the scale you can do it in containers, it's much smaller. So for a very high flow rate, you can do membranes in this container and have a much higher flow rate than we do have a conventional treatment in the same type of container.
Now, in South Africa, with the Cape Town water crisis, now they've been putting in some temporary desalination plants. So is that the kind of application you'd be looking at, where it's temporary, you can install it easily?
Yes, we've been lucky. We've been involved with all these desalination plants with all our customers, and they're using all our aura membranes. So all these plants are temporary. So all these plants have been built in containers, so they are movable. So by the end of the contracts, these containers can just be lifted up and removed to a different site, or go into the specific customer's stock holding. So yeah, that's what they've done. So these containers, all that's outside is maybe pipe work and some other treatment, pre-filtration, but the main RO applications are all in containers, so it's protected against the weather, and it's easy to move afterwards as well.
Okay. And when we look at the opportunities for where membranes can be used, do they open up opportunities? I mean, we're looking at things like desalination. What are the range of applications?
There's a wide range, from just for drinking water application, from surface water, wastewater application, where you can treat sewage wastewater into drinking water, which people sometimes can get their heads around, but we've already done it in South Africa, like in both at West. And then as well, water reuse. Lots of companies, like textile companies, are already doing it in Cape Town, where they're reusing the water from the wastewater to reuse into their system because to save water. And obviously then desalination is a big thing, not just in South Africa currently, but around the world. So all the stuff that we're involved with products, there's not any water that we really can't treat with membranes, and especially as well the mines. There's lots of mines with acid mine drainage and water reuse that they're looking at, and all the membrane technologies are aligned to be able to do that.
Does the thing that you're using it for affect the lifespan? So if you were treating something like wastewater or mine water, does that affect the lifespan much faster?
Of course it is, because as well, especially on the reverse osmosis membranes and brackish water membranes on the RO side, it depends on your application and what water to be treated. You have to use the correct membrane that has been made for that type of water.
Yes.
And sometimes these membranes are especially manufactured for the application, and then they have a certain lifespan, especially if it's a very complicated application to work with. And where you normally have a lifespan of 3 to 5 years, so they have a lifespan of 1 to 2 years. And sometimes the customers are happy with that because they're getting the treated water and they know that. And sometimes you have to need, we have a special anti-fouling membrane. A lot of it's available around the world for different suppliers, but the anti-fouling membranes is especially made for these different applications and for mine water drainage. So yes, for every application there's a specific membrane that you can apply from the suppliers to that application, and will give you the right quality of water that you're after.
Okay, and you did mention earlier about the skills aspect and running the plant. Do these kinds of membrane plants lend themselves better to the South African situation, where we sometimes do have a shortage of skills?
Yes, they do, because we do have good skills on the EPC and OEM contractors, building the plants and designing, but it's the problem where it gets installed and operated, either as a municipal level or private companies. That's why a lot of these installations they sign maintenance operation contracts with the companies building the plant, because they also don't have the skills to run it.
Yes.
So we have the skills locally, but not shared at municipalities. So that's why they opt to be in contract. So you still run the plants for them, even though you've built and operate. So it's not just a straight sell. And sometimes they sign contracts like a build and operate, where you have to install a plant and run it yourself. They just want the clean water. So you operate and take the capital out of that, but they give you, they pay for the operational cost of these plants.
Okay. And when we look at the application of these kinds of plants in South Africa, what has the uptake been like? Are they being installed a lot, or is it still very slow?
They are being installed much more. Not just because of the Cape Town crisis, Cape Town water crisis. There's lots of things happening here, especially on private sector. Lots of hotels and companies and private sectors doing things for themselves. But around the country, we have water issues in PE, Durban, Popo, Johannesburg. So much more is happening on the private sector because people are looking after themselves to have water security.
Yeah.
On the municipal side, it's still a little bit slow. I think the guys are not realizing sometimes the emergency that we really are in the country because we are still a water scarce country.
Yes.
But it's coming. It's long-term projects, sometimes 3 to 4 years for the big projects. But there has been an uptake, especially the smaller system builders. Look at smaller projects, anything from 10 cubes an hour to 100 cubes an hour. Lots of these projects are on the go at the moment, which we're also involved with our customers.
Is there a restriction in terms of output, or is it just the more output you want, the more membranes you install?
There's no restriction. It's just the capacity of our customers. How quickly can they build systems? Do they have to import systems? What can they do? So from our suppliers, any international suppliers, it's just about lead times, how quickly you can supply the product. So we've had lots of inquiries where we can't supply quickly enough the products, because people just need to build systems as quickly as possible because there is no water available, especially in the Western Cape. So there's no problems with the uptake. Currently, it's just to deliver the products quickly enough for the end customer and but for the system builders.
So what would you say is kind of an average timeline to build one of these plants?
Depending on the size of the water treatment plant, I know the CTICC has just awarded the contract for the water treatment plant is going to be installed here.
Okay.
And I think the timeline for that plant is about, if I can remember, 12 to 14 weeks. So it's not because it's a normal timeline, because it's an emergency timeline.
Yes.
So usually standard, in the past, if you had time, because you have to ship in lots of equipment, it's heavy equipment like pumps and pressure vessels and things, and they take time to get here. Some of these equipment takes 14 weeks to arrive at customers. So usually you look at least 3 to 4 months, and the timeline has been cut to more to 2 months. If the equipment's available, they can get it here quickly. People fly in equipment these days instead of putting it on sea freight. So timelines have been shortened. Just because of the dire need to have systems operating.
Do you foresee in the future membranes replacing the kind of traditional treatment plants we use at the moment?
In sub-Saharan Africa, yes. If you look at countries like the Netherlands, they've got both. They're a big country in membrane technologies, and some of our technologies come from there, where they've got both. They've got the conventional plants and they've got membrane treatment plants. But on the conventional plants, the skills they have for so many years are still in the country. We've got the problem where our skills have left. And with membrane technologies, replaces basically these skills. If you put the membrane technologies and you as a customer install and can run these plants for municipal or for private customers, and then it makes it easier for them because you don't have to worry, they just want the clean water. So in South Africa it's much easier because if it's an automated system, the customer doesn't have to worry about all the operation of it, doesn't have to worry about the skills that he requires because he's reliant on his EPC or OEM contractor to install the system, run it for him. So yes, there's definitely in sub-Saharan Africa there's more the move to membrane technologies because it's easy to operate, smaller footprint, and the skills are taken away. You can sit in your home 12 o'clock at night, look at your tablet and make sure the plant's running.
And is there a maintenance aspect with these?
There is a maintenance aspect, obviously that's not just membrane replacement, but maintenance of your pumps, maintenance of your equipment on the plant, like dosing pumps and all these other things. But the operational cost is much lower if you install the plant correctly and run it correctly. So that's usually what we work with customers well, because they want to know what the capital cost is of getting our products, but then they have to look at the operational costs. They really, if we do design work, they want to know how many years conservatively you expect to replace membranes.
Yes.
Because if you know that, you can put it in your operational cost for long term, and it makes in the price of the project. So you can see, okay, but we will get a 4 or 5 year lifespan. We plan to replace in year 5, and that's part of our operational budget. If something happens before that, it's not planned, and then it gets expensive. But if you do it correctly, and the water source is really stable and not too much problems, you get your lifespan that has been predicted for you.
Okay. And in terms of designing the plants, are there special skills that are needed to design?
Yeah, there is
these kinds of
special skills.
plants?
So most of the EPC and OEM contractors, most of the guys are process engineers or chemical engineers. So they're all trained. They must have the skills to know how to design it correctly. And that's why sometimes we help our customers, because from experience we know where the small things is to look for. But all these companies, they should have these engineers that has gone through the university system to be able to know what is correct or not. And that's why we also do, even from our company, we do training on all these different products, so they know if they design the plant, they must remember with these products what you can and cannot do. But sometimes they will design and then later on we'll tell them, no, you can't do that because it's not in the perimeters. So we try to educate and train the customers to say, this is exactly what the product can do, this you can't, and then it's easy for them when they do the design work.
You mentioned earlier that the uptake of membrane technology has been quite good, but are consultants and government entities really aware of the technology and the benefits of it?
Sometimes they are, but not always. That's why we are at some of these exhibitions, and where lots of conferences are going on with governmental guys, so we can educate them as well. I think on a normal OEM guys and EPC contractors, everybody's educated, so we don't really have to tell them too much about technologies. Maybe it's more about what we supply. But certain consulting engineering companies and especially governmental guys, we have to educate them as well to tell them, well, this is the different technologies you get, this is what they can do, and at the end, then this is what we can supply you.
Yes.
Not just to make the sale, because we don't sell directly to the end user, which is the government.
Yes.
We go through the route, but we need them to be educated to understand what technologies are and the different options they have. Otherwise,
Yes.
if they only know about one option, that they'll stick to that option, and there's maybe 5 or 6, which might be better, more cost effective, and maybe easier to get.
And obviously there is the outsourcing option.
Yes.
So what are some of the pros and cons there?
Well, on pros for outsourcing is, you don't have to worry about all the capital costs and all the technical side of it, and you have the skills available. You're just going to get a flat rate of your operational cost, in the sense, this is what it costs me per kiloliter, I have to pay that, and the water goes out. All the stress and issues might be with the contractor, and he just has to supply clean drinking water.
Yes.
So it doesn't matter what technology he chooses, you have to adhere to that quality that you supply to them. And it makes it sometimes easier for governmental organizations, municipalities, because as long as they get the clean drinking water at the quality they require, at the quantity, they're happy. Disadvantage is sometimes they have no control. So if the plant breaks, they're dependent on someone to make sure that the water. So if there's a problem for whatever reason, then you're dependent on someone else, which can be a positive and a negative. But that's why if you have a contract, you must always make sure your contractor has everything in place for the contingencies that might happen. So that the water security is still there, and even if you have lots of storage tanks for water, at least if you have a breakdown, that there's not a problem for your end users at the day, water being pumped to their houses and so forth.
And when we look at South Africa, we do have a problem with aging infrastructure.
Yes.
So is there a place now to step in to assist there?
Yes, there is. If you look at the northern part of the country, or Gauteng as a whole, there's lots of water available now. We have good rains, it's going well, but the aging infrastructure just starts to cause problems.
Yes.
Sometimes people are cut off for a week without water, or a couple of days. So you need to look at installing systems at a point of entry into complexes or bigger estates, and have some storage facilities as well. So you have some type of buffer where if there's a problem with your incoming water, number one, that you have security. And when this infrastructure is fixed and the water comes through, there's lots of dirt and stuff coming through, so the quality is not as good as it was. So if you have a point of entry filtration, and your quality is guaranteed there and going into the rest of the complexes or estate. So there is opportunities there. I think more private guys are taking all of that, like golf estates. I know now in Valdivia they put their own filtration as well, because if you have a borehole available, you can do your own water treatment and be independent.
And when it comes to pre-treatment and pre-filtering, how important is that?
It's very important. Pre-treatment shell membranes are very important. Membranes are sometimes very sensitive, so we do need pre-screening, going to 100 micron. We always say taking out the sticks and stones out of the feed water just to make sure it doesn't damage your membrane. So you have to look at the whole application of pre-treatment, to having self-cleaning strainers, or what types, maybe sand filters that's accompaniment to UF. Lots of times UF and microfiltration membranes will replace sand filters, but sometimes there's a place to have a sand filter installed. So you have to look at that type of pre-treatment as well, and if it is required for your application.
And that will form part of the design process when you design your plant.
Forms part of the whole design process and your whole water treatment.
Okay, and can you maybe give us some examples of good examples worldwide where these kinds of treatment options
Yeah, I
have been
can give
used?
some worldwide and some closer to home. One of them is a project in Sulabia in Kuwait. It's a 350 megaliter a day plant water reuse. The company that we do represent South Africa has been involved with, where they replaced all the UF membranes. So it's a water reuse, so it's a UF plant. So it's about 9,000 modules, UF modules in there, and they've replaced all of those with a special hollow fiber ultrafiltration membrane. And it's going well. It's a big plant, and they're supplying water for the whole Kuwait. Other projects that's been very good is a plant in Uronga in Swakopmund. It's water desalination plant, so they've got ultrafiltration and reverse osmosis there. The plant's running very well, with ultrafiltration as pre-treatment to the reverse osmosis seawater desal. And Windgog in Windhoek, where they do wastewater reuse. They've got a whole process there with ozonation and sand filters, and going at the end of the day, the final filtration being ultrafiltration membranes, and giving clean drinking water to the city of Windhoek. So yes, there's very good applications close to home and far away.
And we spoke a bit earlier about decentralized solutions and for rural settings. Have you installed plants in rural areas that are very well suited to those conditions?
Yeah, we have. We have got other products as well, which is ultrafiltration membranes, but are unique systems that is gravity fed, where you use no electricity for these systems to run. We've got an automated system as well, but with that system, with a small PLC and some valves, you can run off solar panels. And these systems are ideal for these smaller communities because it's manufactured for small flows, but with one step of filtration, they have clean drinking water for the community. Using ultrafiltration, it goes down on these membranes to 0.04 micron.
Okay. Are membrane technologies often energy intensive?
Sometimes yes, sometimes no. On ultrafiltration, the pressures required 2 to 3 bar is not high in energy. When going to reverse membranes, you do sometimes have high energy requirements with brackish water, varying anything from 10 to 30 bar. Then if you go up higher with desalination, up to 60, 70, 80 bar. But we have equipment available throughout the world for energy saving as well.
Yes.
Like with high pressure pumps, we have energy saving products where you can install these products with these pumps and save energy. Use basically the brine of the reverse osmosis to generate power of these energy recovery devices. And we've got energy recovery devices that you can use in pipelines where gravity is fed down for distribution to generate electricity to put back into the power grid.
Okay.
So there's ways of enhancing certain energy possibilities with the flow of the water to generate power as well, and then save you on your operational cost of energy.
And you mentioned earlier that you had a plant that you can run off solar power. So are there opportunities to tie into things like solar power, maybe wind power going forward?
Yes, there is. Depending on the size of the plant, we've seen worldwide there's lots of plants that has been installed with a solar panel array. If you can generate enough electricity to run all your high pressure pumps and your equipment, or at least run the PLCs and all the other equipment with the solar panels, you can do it. There's some plants, I believe, in Israel. It's a big desalination plant they've installed, and it's only running off solar panels. So if you have the space available to put up a big solar panel array, like we might have in South Africa at certain areas, it's possible.
Okay. And going forward into the future, what do you see the future of membrane technology being?
Well, what's good about membrane technology is it's continuing developing. The R&D with some of our suppliers, even it's continuing every year. It's not something that they've developed a membrane and stop. So it keeps on improving. There's always new technologies coming out, new ways of doing certain filtration. If you go to these international water shows which I've been to, every time there's something new that you haven't seen before. So. I think it will just getting bigger and bigger. There's more people getting into it, manufacturing membranes. We might see even in future that membranes are being manufactured in South Africa, on a large scale, not like some of the universities on a small scale, but on a large scale membranes manufacturing here, because it is going to that market where people have the skills and they see a place where they can manufacture. So, and I think we're going into a phase now, it's not South Africa but worldwide, where membrane technologies are the norm, not more a specialized thing where people say, okay, yeah, we can do that, but the cost involved and it's only for certain. It's becoming the norm because you know the quality that you're getting out of these treatment systems. So, if you look worldwide, the amount of huge plants being installed, it's just growing. South Africa is at least 5 or 6 plants that are in development phase, which is going from 50 megalitres a day to 150 megalitres a day, which our country needs, and people are looking at the design of that. It will take maybe another 4 to 5 years, but it's coming.
Well, fantastic, Henk. Thank you so much. This has been a very interesting discussion. This has been CPD on Demand.